Hey, everybody, we're going to start now. Hey, everybody, welcome to Innovate Pasadena Living in Space. Thanks for coming. It means a lot to us. I want to thank Innovate Pasadena and Cross Campus for having us here. It's a really awesome venue. We kill it every time here, so I'm excited. How about you guys? Awesome. So what Living in Space is, it's pretty much a monthly meetup that we do here at Cross Campus, and we discuss living in space, technical side of stuff, economics, anything really when it comes to us leaving this planet, going into space, doing stuff out there. So thanks for coming once again. And basically, I am going to introduce the first guy here, Nitin Arora. And hold on, got it on my phone. So Nitin is a systems and mission design engineer at the Planetary Mission Concept Formulation Group at NASA JPL. His work is focused on formulation of future space mission concepts. His research interests lie in the field of mission design, spacecraft system engineering, spacecraft trajectory optimization, and high performance computing. Nitin received his PhD and master's in aerospace engineering from Georgia Institute of Technology, 2013. Bachelor's in civil engineering from Punjab Engineering College, India, 2017. And 2007. So sorry. Yeah, you got your master's and PhD, and then you got your bachelor's. Okay, and the topic today from Nitin is Ocean Worlds and JPL's next mission concept to explore Titan.
Sheena, are you speaking? Oh, he's not speaking. So you're not speaking. Are you speaking first?
No, you first.
Oh. Can't see it anywhere. It's gone. Oh, that was quick. Hello. Well, thank you guys for coming. First of all, I'd like to thank Yalda, sitting behind on the right, and Srinath, and Patrick, Bryden, and other people on Space Co-op for organizing all of this events all the time. This has been one of the favorite events for me, which I've been attending for the past 2 or 3 months now, along with Loic and my wife, Isha. And thank you all for coming today and listening to me talk about some stuff, which is probably, hopefully, interesting to you guys. But let me start by asking 2 simple questions. First question I would like to ask is, among all the bodies in our solar system, which you know, maybe the moons and even the dwarf planets like Pluto and Ceres, how many do you think have liquid water oceans on them? Just raise your hands. Anybody? Yep. 4? 2? Do you know what twos you guys were thinking about? Two. Do you know how many there are in actual? 9. There are 9 solar system bodies with water on them. Let me ask another question now. If we rank them by the volume of water they contain, where would you think our Earth will end up at? First, second, or any other points? Number 5. Any other? Daring to risk their intelligence? I'm just kidding. I mean, any guess will good, but the actual answer is 7th. So Earth is 7th from the top list on how much water it has. So now, this is what I'm talking about. There are bodies in our solar system which have 6 bodies in our solar system which have more water than Earth, and not by a factor, a small factor, by a factor of 20 or even higher. And JPL and other NASA centers these days are proposing missions to explore these worlds. And I'll be talking about one of those missions which was recently proposed for a $1 billion class mission at NASA. It has not been selected, and chances are probably like 10%. But that's the nature of the game you play. Anyway, so the talk I'm giving today is on ocean worlds. And that's basically, I'll be talking about the solar system part of it and not the beyond, which is the exoplanets. That's not what I'm covering today. So how does it all start? So NASA for the past 20 years have been exploring various bodies in our solar system, and they found that a lot of bodies which were supposed to be dry were not dry. They started way back in Galileo. In 1980, Galileo visited Jupiter. And they were like, well, we are in this new system. Let's look at the moons and all. And they found Europa, which is like an icy moon. And they've then found this weird magnetic field signature at Europa, and they were not sure how it's coming from. Then a few years down the line, in 1998, I think, around that time, or they were able to check that that magnetic field signature matches a signature of a moon, which would have water below an ice crust, a liquid ocean. And when they calculated it, it had more water than Earth has by a factor of 2. And that's a small moon, smaller than our own moon, so of Jupiter. And the way it worked was Jupiter was pulling and contracting Europa and was creating tidal heating inside the moon itself, creating liquid water. But since then, JPL has also worked towards answering the question, if you are alone in this universe, by sending missions all the way from 1970s, when we started sending JPL's Viking mission to Mars. And that mission was supposed to answer, is there life on Mars? But something more interesting was happening on Earth at that point. In 1970s, oceanographers were for the first time going below and seeing life in the ocean of Earth. And they were surprised to see such a diverse form of life there, even when there was no sunlight. And that was a direct link saying, if there are ocean worlds out there, even if there's very less sunlight, there can be life there. And that was another motivation factor when we discovered there are so many ocean worlds. So let's go over some of these before I go into the detail on one of them. As you know, Earth, our planet home, is an active ocean world, hopefully, for a long time. It's a dynamic ocean and supposed life. The second one, which is close to our house, is called Ceres. It's not a planet, it's a dwarf planet. And there is currently a mission from NASA JPL, which is actually circling that planet. It's called Dawn. And we discovered that it possibly has ocean, and it possibly has a liquid ocean, and there might be possibility of having biological potential, but it's still unknown. So this will be a target of next exploration. And while we were approaching that small dwarf planet, we found this white dot, and there were all these theories on the internet. Is it an alien crash spacecraft? Is it Vegas in space or something like that? But it turned out to be deposits of calcium carbonate. And there's also been discoveries of potential cryovolcanoes on Ceres, which is basically volcanoes throwing out huge amounts of water, hot water mostly. So now we don't know what's going on this dwarf planet. We thought it was like a dead small world, but it's probably one of the most active worlds close to the Earth. We want to visit it. We want to learn more about it. The next one, which is the big one, which is one of the main focuses of NASA these days, is Europa. That's the moon which was first found by Galileo, and it is one of the most active ocean worlds which we think is out there. And it's probably one of the best bets to find life in the next 20 to 25 years. And Europa has heat on the ocean, which are basically from tidal heating. We don't know how thick the layer of ice crust over the ocean is, but it's probably on the order of a few kilometers to a few hundreds of kilometers. That's one of the objectives of the mission, which is being launched in 2021, called the Europa Clipper, to discover and understand how thick is the ice crust layer, how thick is the ocean. And potentially, in the future, there might be a mission called the Europa Lander, which will land on Europa and actually try to detect signs of life. And the people in the audience who are working on it from lab. I know somebody's laughing. But more exciting is another moon called Ganymede. Ganymede has on the order of 20 times the volume of Earth in terms of liquid ocean. But the water is locked. So that means it is between two rocky layers. So that's why we call it a locked ocean world. And it is unlikely to support life as we know it. But again, I mean, we are just starting to explore these things. There might be life there, which we don't know. And there's a mission from ESA about to reach there in the next decade called JUICE. It's JUICE, yeah, or yes, it's called JUICE, I think. Yeah, I don't exactly remember the name. So again, that will again be a potential kind for discovery, which we don't know much about yet. Moving on, we go to the next planet, Saturn. Saturn has two major moons, two major interesting moons. It has many moons. One of the major interesting moons called Enceladus. It's a small moon, very close to Saturn, but when we reached there, we found out it was spewing out water from its south pole in terms of geysers. And the water was spewing all the way out to hundreds of kilometers. So we had a spacecraft there, Cassini, for the past 20 years. We thought we can just go through it and sniff it. We went through it, we sniffed it, and we found that it might have a global ocean, and it might even have biological processes going on, but we don't know exactly. And that's why JPL has proposed a mission to go and sniff the plumes of Enceladus. And that's one of the missions which I will not talk about, but it's also part of the same portfolio, which was submitted to NASA earlier this year. It's called ELF, Enceladus Life Finder. And the next target is the one which I will talk about, and that's Titan. That's one of the most famous moons of Saturn, which it is basically a big puffy ball. So say if you want to land on Titan, if it takes 20 minutes to land on Earth, it'll take 2 hours to land on Titan because it's so puffy and you just slowly descend in. And if you are on Titan, you can have wings and just flap them and you can fly because the gravity is so low and the atmosphere is so thick and puffy. So Titan is a very weird world. Before Cassini reached there, we thought it was completely filled with oceans. But it turns out it has lakes of methane. So it has liquid methane lakes all around South Pole and North Pole of Titan. And the equatorial region is full of deserts and sand. Plus, we also discovered Titan has a water ocean, which is below the crust. Now the question comes is, does the hydrocarbons on the lake, like the methane, ethane, all those, can they interact with the water below the crust? If it does, there's all possibilities of having life on Titan. If it doesn't, Titan probably doesn't have life as we know it. And we don't know that. And that's one of the main objectives of the mission, which I was part of proposing to NASA. And I'm going to detail on that after a few slides. So that's the question of whether we don't know if it's locked. We don't know if it has trapped ocean. We don't know if it has a potential of life. People have proposed submarines on Titan as a potential mission opportunities, but still there's so much unknown, we cannot figure out which is the best mission to go. And the last thing which I will talk about today, before I go into my mission concept, is Triton. It's a little different than Titan. This is a moon of Neptune. We have only visited this once, way back in 1980s and late 1980s by the Voyager spacecraft, which are basically now exiting our solar system. We found out Titan is like similar to Europa in some sense. It is cold, it has an icy layer, but it also has active cryovolcanoes. We even detected some of them, which means there is active geological processes going on, along with water, all the way at Neptune. It's very hard to reach Neptune, and we recently had a study about how to get there, how to make a mission happen. It's at least 10 years, takes at least 10 years to get there, and it's at least costing 1.5 billion or more. So this is still in the process, but this is very high up in the next mission after Europa. So if everything goes good, this might be the next big mission which happens after Europa's mission is launched. But just to go back to Titan now, because that's the discussion of my topic today, how does it compare to Earth? So let's look at Europa. So if Earth has 1 unit of water, Europa has 2 times the volume of water on Earth. Titan has 20 times Earth's volume of water. And that's water. That's not the liquid methane lakes. So imagine we have these worlds out there in our solar system. This is our solar system where there's so much water out there. And we have millions of stars, billions of galaxies. So there's potentially billions of chances there has been life all around the universe, which we haven't seen yet. So all this potential exists, and it all rests on us understanding these worlds to figure out how much life exists on other places in the universe. So this is a very exciting time to be alive and be part of this whole journey, and also a very challenging time because it's very hard to explore these worlds because they're so far away and so hard to get to. And this is just the same chart I was showing that Earth is on the 7th. There are total 9 of them. And the biggest one is Ganymede, which is even bigger than Titan in terms of water content. And Callisto is another moon of Jupiter, and it can go down the lane. So let's look at what happened. What have we looked at Titan before? So Titan was explored a lot by Cassini. That was one of its main target. We even had a probe which actually went down to Titan. It descended to Titan and it went to its surface. And I have a video which shows actual footage of that probe going down to Titan. And I can play it. This is actual imagery of that probe looking at Titan. Cool thing about this video is you will see the parachute, the shadow of the parachute go. This is on the surface, and you see the shadow of the parachute go around. That's the parachute. So this was 10 years ago. We should probably do something better. Probably something like this. This is what we are planning. This will be like, we'll send some cute small boats, which we can like move around from here. And they'll be exploring Titan with an awesome view behind of Saturn. It'll be amazing if it gets funded. I mean, it all comes down to money in the end. But I'm not here to discuss money. I'm here to discuss the new mission concept, which we're talking about. And it's called Oceanus. And it's basically, I'm the one giving the talk, but there's a huge team behind it. And I'm not the lead. I was just the lead mission designer. The lead scientist was Christoph Soten. He's the chief scientist at JPL. And there were a bunch of other people involved. So why Titan? Like, I've already given you a public speech of why Titan, but I need to give you a small scientific speech of why Titan. The main reason is it has 3 ingredients of habitability. That was the whole intent of the mission. Can we say Titan was habitable in past? And then can we infer from that what is required for habitability in space? The first thing, it has all the building blocks. It has methane. It has all the hydrocarbons we need to make the molecules for life. It has energy. It traps all the energy. That's huge atmosphere. It gets pretty warm inside compared to other places. And it has liquid water. Now the question comes is the liquid water is in contact with other things? And that's the whole point of the mission, to study that process. And that's why we had these 3 instruments on the spacecraft, which we were proposing. One instrument is called a mass spectrometer. You generally hear this in like sci-fi movies, this kind of instrument. But basically, the instrument is a chemical analysis machine. It'll go and sniff the big the thick atmosphere of Titan and figure out what kind of hydrocarbons it does have, and do the hydrocarbon descend to the surface or not. That's the whole point of the spectrometer. The next is the IR camera. So the picture you saw of Titan before on the left, generally Titan doesn't look like that to the human eye. It's brown because it has such a big haze layer on it. With IR, you can see through it, and you can see if it has lakes, melt pools, cryovolcanoes, and you can see all of that. And this will give us a resolution on the order of 50 times better than Cassini. So you can go really close and see exactly what's going on and see all the lake channels. And finally, we will have an altimeter. The altimeter figures out if there is water ice and how thick it is, and can globally map the whole surface. So at some point, if the thickness is very small and there is a small crack there, well, that means there might be contact between water and hydrocarbons. So we have to detect things like that before we can send a probe. But we do also have a probe which we are carrying together. Now, to explain the whole thing, I have a small slide showing how the whole mission works. I have a small video on showing how the interplanetary trajectory works, how the spacecraft is launched and reaches Titan. And then I won't go into detail on what happens in Saturn when we reach Saturn, but I'll just give a high-level overview of the mission. So the mission starts launching from Earth. You will see it will do a flyby of the Earth again. So basically, it will change the orbit. Then it will do a flyby of Venus. Then it'll come back and do flyby of Earth again. Then it'll do another flyby of Earth. And then it'll finally reach Venus, Saturn. It'll take 10 years for this whole journey because we have these constraints. The launch vehicles on our rockets are not big enough, so we can't send the spacecraft at very high energy. So we need to send the spacecraft slowly from the Earth so that it can do all these gravity assist of different planets and get enough energy to go all the way to Saturn. If we do end up using the bigger rocket, we need to pay NASA more. So the thing is, we have to figure out how to fit in the cost cap, be cheap, and make the mission happen while making it exciting and affordable. So there are all these constraints working. That's why we figured out there were missions possible in 7 years, but we could not propose them. They were too costly. So like this video, oh, I skipped it. So you can see the spacecraft launches from Earth. It'll do another Earth flyby coming back. And once it does an Earth flyby, it will start doing a Venus flyby for that. So it does an Earth flyby. So now it nudges this trajectory. Basically, now it's going towards Venus. It flybys Venus. And whenever the spacecraft comes close to the sun, it gets faster. When it goes away, it gets slower. That's just how gravity orbits work in general sense. So now it does another Earth flyby. And now it's going far away from the Earth, trying to come back to Earth to get even more energy before it goes to Saturn. If we were having a big rocket, like Falcon Heavy from Elon Musk or something, we'll just throw it directly to Saturn. There's no need to do all this dance and waste time. But we can't do that right now because of limitations and money limitations. So it's coming back, and I can probably skip the later part, but it'll do a flyby of the Earth, which will basically, I'll zoom out and then I'll show how it approaches Saturn. Now you can see a big kink here. That kink happens because it changes its velocity with respect to the Earth itself. And that allows it to go reach Saturn. Saturn is approaching, and it's reaching Saturn. So from Saturn's perspective, even though it's coming from the left, if you are Saturn, you will see the spacecraft coming from the left towards you instead of behind you, because it's just how relative velocities work. You will see that Saturn is actually catching up on our spacecraft instead of our spacecraft catching up on Saturn. And that allows us to do orbit insertion in the right way, which I can show later, but I don't think I have videos on that. So yeah, I mean, that's what happens. And once you actually reach Saturn, we do something called SOI, which is called Saturn orbit insertion. So at that point, we have to fire our engines. This is one short thing. If it doesn't fire, we will never get into Saturn's orbit. We need to slow down enough so that Saturn can pull us into its gravity field, and then we stay around Saturn forever. That's how Cassini did it. That's how we want to do it. But that's one shot maneuver, which is always critical. We call them critical maneuvers for a mission. And once we do get into Saturn orbit, so this is coming from the interplanetary side, this is how spacecraft comes in. It comes very close to Saturn, because the closer you are, the less fuel you need to get into orbit around a planet. So it does a critical maneuver here, then it starts getting into this huge orbit, then it slowly slows down, and then gets into this orbit, which is the same distance as the distance of Titan. So it orbits and flies by Titan multiple times, sniffs its atmosphere, figures out what to do, and then finally, after 26 months, it's like, well, I need to slow down more. So it does another critical burn close to Titan, then it starts going around Titan now. It's slow enough that it can just get captured around Titan. So it keeps staying around Titan, mapping the whole Titan's surface for 2 years. And that's where we say mission has ended. I mean, if the mission flies, we'll probably last 10 more years after that. But we have to have an actual logical end to the mission for budgeting reasons. So now I didn't talk about the probe. So what happens is, before we actually go into Titan, 1 year into Saturn's orbit, we actually drop a probe if we want to go a probe on the lakes. So we have a small probe we came up with in a design which is size of this big, and it floats on Titan. And it'll go on the northern lakes of the Titan, and it'll float there, and it'll basically send data back to the spacecraft flying over. Hey, is there something cool there, or is there nothing there to see? And the whole sequence will be, the probe will come in. Because Titan is so nice, we don't need a big parachute. We can slowly descend, and then we just splash into it. And then we do surface operations for like few hours. And even in those few hours, we will take thousands of pictures, panorama pictures. We look below the sea to see this. Who knows? There's a squid there. Who knows? I mean, who knows? We don't know. I mean, this is all about exploration. We can speculate. It probably is not there, but you never know. That's the same thing how we found Europa. We thought, oh, it's a dry place. We actually found water there. So you don't know what we'll discover unless you get there. So that's the thing. So if this mission happens, we do get the money, we can expect pictures like these. This is an actual picture of what it'll look like if we do land there with Saturn from the North Pole. But I mean, if this mission goes through, you will see this picture in 2030s, mid-2030s. If it doesn't go through, that's OK. There's some other cool mission will go through probably. So something cool will happen in 2030s for sure. But I mean, given the NASA budget and the other cool missions, like I said, the likelihood is low. But instead of leaving you guys with a sad note that it might not happen, I would like to remind you guys that we have already done a lot of cool stuff in space since 1930s when we started flying. And we should cherish that. And hence, I just depart you guys with this small video. This is from YouTube. Hopefully, this will work. Oh, why doesn't it? Oh, shoot. Go here. This shows the whole history of NASA, or space exploration, actually.
I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the earth. Liftoff. We have a liftoff. Liftoff on Apollo 11.
Tranquility Base here. The Eagle has landed. That's one small step for man, one giant leap for mankind.
Thanks, Sunesh, for making the video. That's really. So I saw this like a few months ago, and I was like, "This is awesome! I need to show it to people. This was the perfect occasion to show it to people." With that, I think I'm done. Thank you. Do you guys have any questions? You have time for questions? Or are we running out of time? Any questions, guys? We crash on Titan. Titan, because it might have life. It is not planned to protect it like Enceladus is. I know what you're talking about. Europa and Enceladus, you cannot crash on the planet, the moons. On Titan, you can. Unless once we go there, we will discover like, oh, no, we can't crash. But that's a separate issue. But the thing is, Titan only has lakes on the north and south pole. So if you crash around the equatorial region, it's actually fine because it's all dunes. So we have enough propellant for a controlled entry. We did have that on board. But that's the only way. We cannot escape. It's such a big moon. You cannot escape the gravity field once we are captured.
Please ask your questions in the mic because it's being live streamed and people can't hear it.
A comment and then a question. I like how you repeatedly mentioned it's all about the funding.
It is.
Because you're obviously very confident on getting through the technology needed to do all those things. And that's very impressive. I mean, by you, I mean NASA overall, obviously. The question is, you mentioned Falcon 9 Heavy. Is there any conversation around, or is there any idea being floated, or any thought of using Falcon 9 Heavy, or why is that conversation not even being made?
So Falcon 9 Heavy hasn't flown yet.
Right, but yeah, I'm guessing there's some sort of a discussion.
There is. So we have already put that in a trade space. So when we do trajectory analysis, we put some launch vehicles and see which one fits the budget. Falcon 9 is part of the budget. But because it hasn't flown yet, we never propose it as a first choice. It's like a backup option. If we had it, it'll be cheaper and we can use it. We always say it like that because we don't have it. It's not flown yet. And the Atlas vehicles, which NASA actually uses from ULA, they have a huge record of success. They don't fail easily. Here's what. But they have a huge record of success. So those missions, so it's very hard to overcome something like that. So that's why Falcon Heavy still needs to prove it is reliable enough for us to actually use it for launching in space. But I'm all up for it because it's 10 times cheaper. So it's potentially game changing once it happens. Hopefully later this year. That's when we have first Falcon Heavy launch. Any more questions?
Do you think it's more likely to find life on Titan, Europa, or Enceladus?
Yeah, I mean, I'm working on Titan mission. What do you expect? Yeah, but I mean, no. I think the lowest hanging fruit is Enceladus actually, and that's Sonia. She just went away. There are a couple of more people here. They were working on that mission, and because it's just you can just go and sniff the plumes and figure out if there's life or not. It's such an easy mission to do compared to all of these missions, which have to like land and check. But the chances that mission is like one thing. If you don't sniff it, you just spent $1 billion for nothing. So I think Enceladus has the most highest chance of finding life if the life is there. But just chances having life, I think it's Europa. Europa has everything right for the life to exist. It's just a probability now if it happened or not. And that's why we are sending a mission there for sure in 2022 and a lander hopefully following that.
Hi. So
I mean, the decision whether or not to fund it is being made by NASA, obviously, which is a public agency. So the decision might have to be justified, to the public in the future. And thinking from the eyes of someone who's not a scientist, the average public member might say that we just had Cassini, which was a mission to Titan. We went into probe on Titan. Yours is a mission to Titan, which is then into probe on Titan. The two sound very similar. How do you justify that we should go to Titan again rather than going to one of other Saturn's moons?
You talk like a reviewer, like a NASA reviewer. That's exactly what they think, and that's exactly what we have to do to convince them. So that's the reason we will not answer any questions Cassini did. We are basically building upon the questions asked by Cassini. So Cassini asked us a bunch of these questions about Titan. Now we don't know. We are in this unknown region. Same reason why we go back to Mars all the time. We went to Mars back in 1970s. Why did we went back again in 1990s? Then in 2000s. Then in 2008. Then 2012. Curiosity landed there. Why? Because we're building upon the questions asked by previous missions. And that's always how scientific process works generally. And I'm sure if you go to Europa, we will not know everything. We'll say, oh, there's probably chance of life there. Now we need to send a submarine there. So, you always build upon questions asked previously. You can't send this one mission because you don't know what you will find. If you knew exactly what you find, what's the point of sending it there? So, there's always this tension between doing something completely new or doing something which is building upon questions of others. So, and that's for NASA to decide which one they want to go forward with. We just want to do cool everything. I mean, ideally, we want to do everything. So, but that's something we cannot do right now. Any more questions? Are we done?
Let's see. Is there any place where the public can look up these NASA papers and look at the proposals?
So proposals are not public because what happens is we are competing with other NASA centers. Like JPL competes with Goddard, APL, which is the center which is doing New Horizons, and other NASA centers. If you make them public, they will know our secret sauce. So because we all kind of internally having this competition, we don't make it public. We make the science public, and we make presentations like these public. But the details are not really public until many, many years down the line, when the mission has already happened. Yeah, then it's all fine. Or when the mission will never happen because it's just too old, the science is too old, it's not impressive enough. So missions from 15 years ago might be public, which were proposed, but the recent ones are very hard. You can find the science for sure, but the engineering is not easy to find publicly. I mean, this is the closest you get. You get like these view graphs.
That's what I mean, like the scientific papers that underlie. Like.
So yeah, I mean, there are scientific papers on AGU, which is the American Geophysical Union. It's a big conference which occurs everywhere, and that's where people go and present. But you can go it on NASA's website, even JPL's website, and most probably find those papers around. But you won't be able to find Oceanus itself. Interestingly, the only place you can find Oceanus mission is on Wikipedia, and every other mission is also on Wikipedia, and that's the only place you can find it actually. Because we don't document these things for a reason, because we want to propose them again in the future. And if we show them what we're doing, the other centers will trump us, sorry for the word, but copy us, So, any more questions? I think we're done. All right. Thank you, guys.
Am I going to introduce live? Thanks, Nitin. That was really inspiring. Okay, so we have another speaker coming up next, Loic Chapas. He's a mission design lead at Astrolabs, a high-tech startup company in the field of space missions and flight system design. And his research interests include trajectory design and analysis in complex dynamical environments and extend to any space exploration topic. 2011, Loic obtained double MS degree in aerospace engineering from Purdue and his original school in France, ESTACA, before completing his doctoral degree at Purdue in 2015. And the topic today is a new space roadmap for living in space. Give it up for Loic.
Thank you, sir. All right, thank you all for sticking around. I'm going to try to set a timer so I don't talk your ears off until morning, since I'm not really actually prepared this very well, we don't know how long it's going to last. So actually, Nitin perfectly set up the stage by saying how hard it is to do what we are trying to do. I'm going to take a slightly different perspective on it and trying how do we go from here and actually send people around to see those places, not just robots, but people. What would it take from today until maybe another half a century for us to be completely Earth-free, if that'd be the goal? So I'll start from home. Home, like Nitin said, is convenient. There's an atmosphere, there's some organics, which is always convenient, and there's also water, good friend water. And so far, we've been doing a lot of space stuff. The last video Nitin showed was quite amazing in that regard. And what we call now in the industry kind of old space, where it's mostly run and defined by governments and governmental agencies and very big corporations. And one of the issues we had is that it's very expensive to get to space. Those launches cost hundreds of millions of dollars to send stuff to space. The other issue with that is, like Nitin was saying, they propose a mission today. It may take years to be accepted, years to be designed, years to get wherever it's going. And so at the end of the day, you have some people who start working on a mission when they're like 25, and it's they're in the mid of their careers, and the spacecraft hasn't even left the launch pad yet. And so that's kind of what here is. These big structures, this is a typical geosat commercial spacecraft. They weigh a lot, they cost a lot, they take a long time to develop. And then, about 15 years ago, something came about that they called new space. I like to say the billionaires found a new hobby. Those are the Elon Musks and Jeff Bezos and sirs and ladies who had just a lot of money and didn't know what to do with it, so they decided to do some space stuff. And it's great because it's really working out for them and at the same time for us. A bit more recently, what now we actually really call new space is really happening. And that's not just the big guys, but there's a countless number of new startups over the last few years and just still coming up almost on a daily basis. And those guys are able to just get in there and develop new tech, new ways to launch things to space, to operate things on a much faster time scale at a much lower cost. And so now you have these guys like SpaceX and Blue Origins, and the cost of access to space is dramatically decreasing. And we also have those CubeSat and SmallSats. So this is now an actual spacecraft. It does, well, not quite as much, but it is self-sufficient. It can get in orbit and it can do interesting things. And this is to scale. This is someone's hands. It's literally a small cube. It's what we call them CubeSats. Not very original. We have also big small satellites. This is again to scale. It's the next generation of satellites that are supposed to provide internet everywhere on the globe. That OneWeb is developing those guys. And instead of just launching one, we'll launch a lot. OneWeb plans on launching about 1,000 of these guys in low Earth orbit and then use those constellations of spacecraft to provide services. But because they get so cheap to manufacture, to develop, to launch, it still is economically viable. So that's where we are today, kind of state of the industry. What we've been doing is mostly, because eventually one way or the other, whatever people may believe, we're gonna have to leave our planet. Even if you don't believe that we may just, annihilate everybody with nuclear warheads, that if we manage to dodge every asteroid that's coming our way, which there's a chance we do, if climate change just reverses itself, eventually the sun is aging, it's gonna start expanding, temperature is gonna start rising, oceans will be boiling, the atmosphere will be just also vaporizing. Either way, it's not gonna be pretty and we will need to live. So if it's not today, if it's not in 100 years, it will have to happen. So might as well have some fun along the way. So from here on, so far we've been playing with what here I label exploration. We've been sending robots, a few humans here and there, to try to gather knowledge, test new technologies, kind of start to make our way out, and also because it's cool. So robotic exploration, we've been doing a lot, and Nitin showed a bunch of that stuff already. Most people don't realize that we have probes and spacecraft and rovers kind of all over the sort of system, learning about the planet, the bodies, and just testing those new technologies that eventually will help us get off the planet. As far as human exploration, that's still a work in progress. We've been doing a little bit of it. We have people in the International Space Station permanently, which is good, but it's just literally above our head. It's much closer than going across country. It's not quite that far. The moon is much further, so that's an actual destination, and we haven't gone there in a little while, as I'm sure you all know. So that you have to get better at. But from exploration, we want to get into colonization. That's a bit more complicated. We'll definitely need both the robots and the humans together, and there's a few challenges. Some of them we have some clues about how to go about it, and some of them I think we still have kind of a long way. And those are pretty much transport, food, shelter, and workforce, all 4 axes that if we don't solve, we are gonna have a hard time not being around here. First one is food. And one of the main challenges is humans are weak. We need to eat a lot all the time. If we were like plants, it'd be much, much easier. And some of the way we could potentially do that, this is kind of an artist's rendition of what it would look like on Mars. You have these biospheres where you just grow stuff in an artificial environment. Of course, eventually we want something that looks like this. We have full-on cities as we know them in space in some kind of artificial gravity environment. This will take a while. What we know to do today is this. We have those in the deserts, and aside a few facilities, they send people in those analogous missions. They spend weeks, months in there and try to be autonomous. But from here on to the actual fully developed permanent human shelter somewhere on the planet, there's a long way to go. So that's the first thing, food. Food is hard. But food is probably the easiest. We will also need to be able to manufacture things off-world. It's not sustainable to just think we're going to keep shipping things into space and then sending it to Mars, sending it to Enceladus, all those planets. It takes too long, it's too heavy, it's too expensive. What we need to be able to do is manufacture stuff off-world. And that's a video from a new startup actually called Off-World, literally, they didn't go too far. And they're trying to develop, and I say trying because it's not going to be easy, a fleet of smart robots. Those robots will just be able to do whatever you tell them to do. They'll go around to Mars, to the moon, to the asteroids, and they build stuff for you. Before we get there, while we get there, doesn't matter. So those are the little guys. They're supposed to be able to do pretty much everything, including self-replicating themselves and 3D printing material using in situ resources. If they can do it, because the first step that they're currently working, this is kind of a embellishment to where they are. They have a drill today and they're trying to train the drill to drill appropriately. But eventually, you'll be able to have those guys just go around and dig tunnels for shelter, deploy solar panels for energy, and all these kind of fun things. So let's run that through a little bit longer because the actual more interesting part's coming soon. The next step for them is what they call genus asteroid, genus lunar. So those are asteroids and the moon. It's, again, using in situ materials to do things. So develop solar panels for electricity, or on Mars would be to just, again, kind of the same theme is use resources that are there to build things. We cannot afford to just send everything each time we need something. So those robots hopefully will be helpful. On the same vein, off-world manufacturing, in space manufacturing, a bit of the same, but we also need structures in space, whether it's relays, maybe fuel depots, other type of structures. And so that's another startup. This is why new space is kicking in. They're called Made in Space. Again, they don't go too far for the names, but this guy is supposed to be a telescope, essentially, or a radio relay. But you just send the bus, the actual dish will be deployed and 3D printed to some extent in space. So it just has these prefabricated small panels. It will do some inspection to make sure they all to properties. Use 3D printing to actually seal them all together, and then it will just beautifully deploy when you need them. And again, this is to save volume because there's only so much room in a rocket. Even if you can afford the mass, often you cannot afford the volume. So those big arrays like telescopes and antennas, like you see now, when they expand, they take huge amount of space. So from a fairly compact bus, or we call the main part of the spacecraft the bus, from main compact bus, you can get to a fully functional radio relay or telescope. And that boom is actually being 3D printed as it goes through the bus. Another thing they're trying to do, same company, is to create full-on structures in space. So now these kind of tubular structures that you can use to as a framework or as an overlaying structure. Either it's to put in habitats, to just use as a structure to host spacecraft or other things. So the same principle is this little guy just leaves as it is. He's got a source of material and he starts to 3D print whatever it needs to assemble in space a tubular structure in this case. So without like fancy videos, obviously none of these people actually have anywhere close to anything that looks like a prototype. They spend, I think, most of the time actually doing pretty CAD and videos, but nonetheless, there's really nothing technologically speaking that stops us from actually doing it. Well, maybe Nitin would say money, and he's right. It's all, at the end of the day today, from money. So this is what it would look like eventually. As it is, maybe not very useful, but you can imagine how this could be useful in some instances. Shelter, because again, humans are still weak. If we put us just in space, we don't make it. If you put us on the surface, we may not make it. There's a lot of macro meteorites impacting most bodies constantly. The temperature is just awful, honestly, and I don't mean like from a South California point of view. It's just not sustainable. And also there's nothing to eat or to drink. And for that, we do know how to do this to some extent. We can just stay up there. That's a concept from NASA with their kind of new roadmap to Mars using crew module, and this is a bit more longer term, but kind of a permanent module around the moon. Other way is just to go below. Of course, we're not there yet. Again, this is more like what we're looking at today, a underground habitat for humans, maybe using lava tubes or the caves, whether it's on the moon or other worlds. Or we can build on the surface. And that's an effort ESA has been leading lately, where they're trying to set together a concept for a lunar moon village. So it's mostly using inflatable structures that you can ship, which is kind of semi-optimal. Again, we need to send all that mass to the moon, but then it's actually using in situ resources to 3D print the rest of the habitats. And one reason they do that is for radiation. By using the ground, the regolith, as an insulant, you can shield humans from radiation, and we can not die, which is always kind of the end game. So there you go. We'll just 3D print to some extent the structure of the habitats, and that will shield people from the harmful radiations. And you can do that and repeat. And at the end of the day, you have a small, nice village. So the actual structure and the thing you need to ship is not too extensive. A lot of the labor is using in situ resources and materials that they're right there on the spot waiting to be used. The last part is a bit more tricky, and that goes back to also some of the things Nitin was saying about how long it takes us to go, say, from the Earth to a planet a bit further away. For this mission concept, it's about 10 years, and that's just too long for humans, most humans. If you want to be able to have a sustainable colonization and it takes you 10 years to commute, it's not going to be very convenient. That's one thing. Transport techniques are slow. It's super, super fast, but on the scale of the distances we're looking at, it's just too slow. But the bigger problem is human health. The challenge again is human, and then I can guess the rest. Human health in space, we're not meant initially, at least, to just be able to travel in long distances in space. The bigger challenge is radiation. So the harmful radiations, well, sometimes you may have heard of cosmic ray radiations. Spacecraft themselves do not insulate from that. So if you spend months or years into space, you will most likely not be okay for very long after that. So with that, we need to figure out. And there's been, quite frankly, not enough work done on that. And I don't think anyone has a good answer to that just yet. Either we have to modify ourselves directly using those new kind of gene therapy or other biological ways, which a lot of people might have issues with, or we need to build better spacecraft. And most likely it comes to just making the spacecraft heavier, bigger, and that's again more mass, more money, more problems. So that we haven't figured out. For scale, the moon is quite fine. It's just a few days away. You don't die from that. Mars is still more or less doable. If you go back and forth a lot, you're going to start not being happy with yourself. But if you want to go further, like Pluto, and it takes you 10 years to go there, you will most likely have cancer by the time you get there, which is, again, not quite the end game. But so anyway, so there seem what we call technological gaps, but for most of it, we have ideas. We know how to do it by kind of breaching governmental agencies, big companies, and new startups. If they all come together, we have a good shot of actually making this work. So what have we done so far? If we go back from the beginning, the moon. The moon has a few issues. There's no atmosphere, there's no organics, and there's water to some extent, but it's not kind of readily available. But the moon has some good advantages. First, it's close, so we have transportation to get there already. SpaceX, Blue Origins, they have now also those crewed vehicles that are almost ready to go, and so it's kind of easy-ish to commute back and forth, or just to go and develop your whatever infrastructure you may need. The moon is also good in that sense that it's easier to get stuff there, so we have a good way of sending the materials we need to build shelter. So transport, shelter, tourism, actually, because there's been a few proposals already, not from NASA, because they're not really playing in that game, but from private companies who think that it could be an avenue to actually bring funding and outreach. Of course, this picture is not quite accurate just yet, but eventually you may have a pool on the moon. It'd be fun because you splash the water, it can go really high and take a long time to come back down. And also, I think what's actually the most interesting about the moon is it can become a hub. There's less gravity on the moon, there's less people in the moon, there's a lot of in-situ resources, so you can go there, build fuel depots, build just like an airport, essentially. And also, it's not right above our head. So if people get a bit antsy about having a lot of, large tanks of flammable fuel just sitting in orbit around the Earth for space exploration, a lot of traffic up and down, the moon is remote, but not so remote that we cannot leverage it. So that's, in my opinion, one of the biggest draws to the moon. But that's just the moon, and not a lot of people talk about let's colonize the moon. It's not quite as, I guess, sexy enough. Everybody wants to go to Mars. And Mars is actually a pretty decent place to go to. It's got an atmosphere. It's not breathable, but I mean, we can worry about that later. It's potentially got some organics, and if it doesn't, we can use both the regolith in the atmosphere to make what we need, so we can actually get food. Water is a bit more tricky, but we also know how to make that. So all of those things are not showstopper. And in fact, SpaceX have been pretty vocal about it, saying that they're going. And by SpaceX, I mostly mean Elon Musk. I think SpaceX does whatever he orders. Let's see if I have a bit of sound. Maybe not. It's a very dramatic Elon Musk-y type of music, and it goes very well with the animation. But the point is they're developing these extremely ambitious that most people are very actually skeptical about the timeline, and that's a very nice way to put it. Mars transportation system to literally send dozens and dozens of people to Mars in the very, very near future. And if that works, honestly, it's going to be pretty wonderful. They have still a lot of technological gaps. They haven't really talked about how they're going to address some of it. And the radiation one is one. Don't talk too much about that guy. But they are building that infrastructure to be able to get people from here to there and stay there. Also, you want to try the music? It should be on. It is on. It's not very important. But anyway, so they're developing both the launcher, the crewed vehicle to go all the way from here to Mars in a relatively reasonable time frame. That's also why they don't talk too much about radiation. They just hope it's quick enough that it'll be okay. And land on Mars and start developing the infrastructure you need. They also plan to send a bunch of these guys empty at first, just with stuff, to be able to build it and develop, again, the housing, maybe the food processing plant that you need to actually sustain humans. Eventually, when we get better at, again, building in space and building off-world, we won't need quite as much preparation. We'll just be able to send people and send just the tools with them and just build everything on site. I should probably also mention that I've kind of brutally edited the video to make it shrink from 5 to 2 minutes. So there's a lot of passages here that are gone. I don't want anyone at SpaceX to get, antsy or angry. This is not the full artwork. But nonetheless, it kind of depicts whatever they're trying to do, at least as of today. And so about 3D printing, NASA actually has a contest. If any of you guys have good ideas about how to build a home on Mars, there's literally a contest going on to submit all those stuff of proposals. It's really good to have an idea of how to do it with the idea. I think they like that better, but idea is always the starting point. And it's not that far ahead. This is a Russian company, and they just built this house in 24 hours using 3D printing. Of course, they can use humans as well, so it makes things slightly simpler. But the actual, most of the structure of the house was 3D printed with cement, as it's shown now. And they just had to kind of stick in the windows a little bit later, put in a coat of paint, and eventually the house was ready. So, I mean, that's another point about space exploration that a lot of people forget. A lot of this technology drives innovation on Earth too. This can be used to solve a lot of crises of lodging, obviously, but a bit about throughout the Earth. But mostly we are interested today, at least, to just export that somewhere on Mars or somewhere else. Because so we looked at home, we looked at the moon, looked at Mars. There's been a lot of interest into asteroids too. You might have heard of planetary resources and deep space industries. Those guys want to mine asteroids for resources, for water, for other raw material. And they have also very, very bold plans. So this is deep space industries, fuel processing plant, or whatever it's called. But the point is that it goes, hooks on an asteroid, drain it, and use it to process rocket fuel. Or they have concepts similar to the ARM mission from NASA, where they'll go to an asteroid, grab a big chunk of rock, and bring it back. Obviously, from what we've seen, like the spacecraft we fly today, to these type of guys, there's a long way to go. But you can imagine that all these structures can be 3D printed by our other friends at Made in Space. The robots can maybe put some solar panels on top of it, and then we're almost there with a leap of faith. Planetary Resource does kind of the similar stuff. They want to do same thing with asteroids. So it's not really said, but when they grab that asteroid with the bag, they want them to like warm it up really, really hot and extract the water. From the water, you can obviously just use it as water. And they also have a concept to make rocket engines that use water as a propellant. And this is a more concept of, let's go to an asteroid, dissect it, take the material we care about, and do something with it. So those are asteroids. Now, like Nitin was saying, Ceres has been of great interest. So if we just think a bit forward now, like forward like about 50 years, and we have all that tech from the startup, from NASA who's still helping, from the big companies now that are very well established, and they have developed some of those tools, we can maybe think about how we get to live on Ceres. So first thing, we send deep space industries, and they have that fuel processing unit, so we have fuel for using on the planet itself, to get there, to get around, to go back and forth. We can use those little guys from any space to build the structure in space that we need. Maybe you need a communication relay, some other structures just to do cool space stuff. We have those robots who can just go back on the surface, deploy solar arrays for electricity, or build other things you may need, up to the point that we can build those small villages and live on the surface, although that'd be kind of a temporary solution. Eventually, you really just want to maybe go underground, have this nice mall, lodging, and have a bit of fun on Ceres. And for those who recognize it, this is actually from the show The Expanse, so it's not really a current viable design concept as much as a sci-fi TV show. But the idea is pretty good. Anyway, so that's on Ceres. Then we can also go beyond. Nitin, and I won't get into this because Nitin covered the subject extensively, but the big, large water worlds are obviously a target of interest. These get slightly more tricky if it was not tricky enough till now, mostly because now the travel time is huge. There's just no way to get around it with our current technology. We just need to get faster or just do something different. So warp drive or teleportation, either way, it would work, but our current ways to move in space is just not good enough. Radiation is also an issue. As long as this travel time is so long, most of us will not be okay by the time we get there. So that's kind of an overview of where in the solar system we could go, what we could use along the way, what kind of companies are doing things today that help us, and kind of what are the gaps that we still need to bridge. But that's just kind of the first step, exploration, colonization. What you really need to think about for long term is about civilization. It's good to go, it's good to develop things and to live there because it's fun, it's cool, it's new. But to be sustainable, you need to think about models like governance, economical models, and social models. And those are way more trickier than the technological stuff itself. And that's, I think, where most people will start to disagree. And I stole those terms from a form Yalda sent me earlier yesterday, the avowed nihilist or the unflinching optimist. There'll be two competing interests at some point. Do we export models from Earth as far as government, economic, and social go, or do we use this opportunity as a fresh start and create new paradigms, new models? Can we do it differently? Do we want to do it differently? These type of questions need to be asked, and they mostly need to be answered and thought through now, because by the time we get there, it'll be essentially too late. And if you want to learn more, feel free to get in touch with us, with Space Co-op. We'll be also here after the talk. We're happy to chat, and shoot us an email, and we can definitely talk some more. And with that, that will be it. Thank you. Question time.
Once we colonized, how do we create a breathable atmosphere?
How do we create a breathable atmosphere?
Right.
I mean, you want a technical process? No.
Can we do it?
Can we do it? I don't think, I mean, we cannot do it today. There's no reason why we cannot do it later. The question becomes, do we even, does it make sense to do it? How long would it take? What would it take in terms of energy and honestly money? And does it really bring in something viable? And at the end of the day, it's a whole ecosystem, right? If we just change the atmosphere, we're not going anywhere. You then need to also change the soil and everything that goes with it, because it's an exchange, right? The atmosphere goes into the soil, the oceans, or whatever other sources you might have, and the whole thing needs to work together as an ecosystem. And this is way beyond my skill set, so I'm just giving you thoughts as opposed to actual answers.
So I know you've worked in this area a lot. So I have a question. Have you seen these companies competing with each other, or are they like collaborating? Because a lot of innovation happens when there's competition. But from what I understand is there's more collaboration going on right now. Do you think that will slow down innovation, or will that result in more innovation? Because every advancement generally happens when there's competition. At least that's how humans work. So.
Yeah, no, I don't think they're really cooperating yet. Okay. I'm putting them in a framework where we could all work together. But no, deep space industries and planetary resources will compete and are competing for business. They are all companies to begin with, and they want to make money.
I was just wondering, in terms of shooting off rockets into space and with new space with lots of private interests, which laws govern who gets to launch where, what trajectories are public knowledge, you know, crash risks, trash in space? Like who's in charge of that?
No one.
All right.
No, there are some. So in the US, you need to get a license from the FCC and then from an approval from the FAA to launch and all. But the truth is, that's only good in the US. Each country will kind of apply their own rules to launch. Once you get to space, there's really nobody that has the authority to tell you what to do and what not to do. And that's why you have a very big graveyard of satellites in orbit doing nothing. Eventually, someone will have to do something about it, but that legal framework does not exist yet.
Okay.
So I was wondering if you were a betting person on which place would go first after the moon, what would you guess?
After the moon? So Mars then is kind of the most likely answer. There's a lot of debate whether or not you should go to the moon or Mars first. That's a very different debate. But assuming you have something going on at the moon, then Mars makes most sense to me.
Yeah, that's what I was going to say.
It's true. So he's saying Ceres and the Moon, for the people watching online, if there's anyone, that they have similar environments or similar technology. It's true. We know a whole lot more about Mars today than we know about Ceres. We also have an atmosphere on Mars, which we like. Yeah, so we know a lot more about it. We kind of already know what to do and how to deal with it. And it will remain closer. And SpaceX is going and they're putting billions of dollars into it.
So in this, the whole sector of new space and all these startups, not many, I think almost none of them have actually flown stuff, or it's a very small minority. Do you see any of these, like, do you think that there's one or two that will have these technologies within the next 5 years?
Yeah, so there's a few who have been pretty good at it. And Planet has launched dozens of spacecraft, and they're going to go to the hundreds very soon. Spire has launched a few. SpaceX launched pretty big things. Blue Origin is going to get there really quickly. So no, there will be a very big handful of strong companies coming out of that ecosystem, and there's a lot more coming for sure. It's been slow to wake up, but now the venture capitalists have realized that they can make money from space, and so they're really pouring a lot of investments into it. And with the new kind of smallsat, CubeSat, it gets easier and easier to actually get space platforms up there. So it's definitely going to ramp up and explode.
I also noticed that you left out Moon Express, and there's another one, I think, that they just announced today that they want to land on the moon by 2019.
Yeah, so this is just a few that I just Googled and copy-pasted on the fly to fill the slide. There's a lot more. There's, for the moon itself, there's Moon Express for sure. There's all the other contestants in the Google Lunar X Prize. And there's also some other private companies who have, as a withdraw, not just not compete, but are doing kind of the same concept. So yeah, there's a lot of people going to the moon to do one thing or the other. Yeah, it's coming.
What sort of resources are expected to be found from asteroids, and do they plan on bringing them back to Earth or use them in space, or what's the plan on that?
So I'll tell you what I know and what I think they'll do. Mostly it's water. They want to get the water of the asteroids either to use as a resource directly or to use as propellant. And then just other, I mean, there's a small market for those precious metals on asteroids, but in the long game, I don't think this will be very prevalent. As to bringing them back to Earth, I think for now they're trying to develop infrastructure to use them there or beyond, just because it's as expensive to come back as it is to go, so it's double the price. But eventually, if, say, water is a scarcity on Earth, there will be a market for it, and if people are willing to pay for it, obviously, there'll be a company doing it. So, yeah, bringing stuff back from outer space to Earth is definitely in the possible future. Any more? One more?
What do you see as the ideal or alternative government or economies in space?
I have no idea. I think about it every once in a while, and I never get anywhere. So yeah, I really don't know. And I mean, on the level, I think I'm not necessarily qualified for that type of debate. At the same time, I think if I don't think about it, then we kind of screwed either way. So I think everybody needs to think about it, but I really don't have an answer today.
I mean, to answer that question in some way, there's this space nation called Asgardia. It's like this guy in Russia. He just founded the space nation. Yeah, I'm a MMO too. But I mean, it's like this utopian governance. We'll just everything will be awesome and happy. But we don't know what will happen. It's a very evolving process. We don't know what will happen. There'll be Star Trek or there'll be Star Wars. We don't know.
Can I? Oh, yeah. Nitin, they tell me you have to stop talking.
Hello, my name is Yalda, and I'm one of the co-founders of Space Cooperative and also one of the co-organizers of this meetup. And I'm going to tell you a little bit more about Space Cooperative and what we're up to. So what is Space Cooperative? We are a network to enable global collaboration on large-scale space missions. I know that sounds crazy because you need a lot of money for large-scale space missions, so I'm going to start to describe how that will work within Space Cooperative. Essentially, within the network, users will have the ability to organize into virtual or also local working groups, and there will be a decentralized, autonomous operative mode. Like, although Space Cooperative is launching the network, we don't see ourselves as the leaders of the network. That's self-governing. The community elects who is on the advisory board, essentially who is leading the space missions. How will this all work? How do you track what's going to happen? We're going to have a cryptographic token or a cryptocurrency, and that will be a representation of membership, and that will, give you rights on, voting on different space missions. You start to rack up points of sorts, so it'll be a gamified ecosystem. So yeah, if you don't know what a cryptocurrency is, it's a digital asset designed to work as a medium of exchange using cryptography to secure the transactions and to control the creation of additional units of currency. So if you've heard of Bitcoin, Ether, the blockchain, that's what cryptocurrency is. And it's very useful for trying to create a global space agency, because if you want to, work with people from all over the world, you don't want to have to, work with so many different types of currencies. If you've heard of Second Life, whenever you go into Second Life, you buy Linden dollars. So it's like a virtual world. And although in Second Life, that token is not cryptographic, it is still like a virtual or a digital currency. So you're going to need a similar type of thing if you want to create a global online space agency of sorts. So this is a great quote by Buckminster Fuller. If you want to teach people a new way of thinking, don't bother trying to teach them. Instead, give them a tool, the use of which will lead to new ways of thinking. So that's why Space Cooperative's first product, it is a tool. It is a social collaboration platform. It will have different space missions. For right now, the missions are more large scale as maybe more program level, like, Mars, etc. But the missions, there'll be discussion forums, there'll be profiles, you can see what people's skills are. So it'll have a lot of similarities to the tools you use today, but it's taking a few features from different platforms that you're familiar with, but combining it into something that would be useful to actually collaborate on space missions together, to see what people's different skills are, what they have that they want to offer, what they have that they want to contribute. So this is the initial tool, and with this tool, there will be the cryptocurrency within it. Whenever we launch, we're not going to have the cryptocurrency, but that is something that's in the roadmap that will lead towards actually realizing the space missions. So yeah, as mentioned, for large-scale space missions, the budget of a government is typically needed. But what if we had a strategic crowd? So how does this all work? How do you actually make things happen? There are going to be different roles within the network. People can be coordinators, experts. There are going to be people that are just learning, so more like apprentice types, and also committees that are, the people that have probably worked on space missions for 20 years. Maybe that's someone that recently retired that just wants to contribute a few hours a week overseeing some concepts. But then there'll also be investors, enthusiasts. You're going to have more in this network beyond just space missions, but also, eventually entertainment, even virtual worlds. So for actually accomplishing the real life missions on there, you have to propose the missions, define the requirements, design and develop the concepts, just like Nitin just presented the Titan. That's a concept. That's something that they proposed to NASA to try to get $1 billion or $500 million to fund it, to then actually take it to the next level. So it's like, how can we try to do something like this and open it up to the public to actually teach people about space mission engineering and inspire them to go work for JPL, go work for NASA, or just be part of Space Cooperative. So essentially, the platform will have different projects, even Earth. You can battle climate change. There'll be different contributors, and there's going to have to be a giant work breakdown structure for each type of mission. And then based on what people contribute, be it time or money, the cryptocurrency will hold the accounting system for what people, for, the different points that people have. So that's what I'm talking about, the gamification of the system. So how does decision making work? So there'll be standard members, but then also an advisory board. If you are a token holder, then you can vote on who is on the advisory board. And the advisory board will hold special tokens. So for example, the advisory board will have a 50.1% control. So for all of the tokens that they have these special voting tokens. If there's consensus amongst the advisory board, then they can approve decisions, but the standard members still have a vote too. So if there's not consensus with the advisory board, then the vote of the members can tip the dial in different directions. So this is an initial governance that we are proposing, but it's nothing that is stuck in stone. And as it is a self-governing network, things like these can change. So strategic planning, whenever we launch the network, it's going to have different mandates like social purpose, research and development, and near-term revenue, because you should try to monetize some projects on there, but you should not also you shouldn't only prioritize making a profit. You need to invest money into research and development as well, and also social purpose projects. So we think it's important to have a balance of different types of projects. So, you have the mandates, programs, missions, projects, tasks. That's a high level breakdown of how this strategic network would work. So if you want to read more, there's our blog and our website. There's not that much on our website yet, but we're starting to publish more on our blog right now. So I was just trying to give a brief overview. And I'll also be talking at the Starship Congress that's happening next month in Monterey, and the International Astronautical Congress in Adelaide. And then a couple members will also be presenting at the Mars Society, 20th International Mars Society Convention. So, yeah. And yeah, that's it. Okay, and now Patrick's gonna introduce the jam session.
Thank you, Yalda. So Los Angeles has one of the worst rental and housing markets in the entire country. How many of you guys are renting right now? And I'm assuming the rest of you either have an awesome van or own a house, yeah? So why would I be at a space event and asking you guys about rental markets in Los Angeles, and why on earth does that matter? So in our first presentation, we heard about the search for life on different worlds, specifically in this case from Titan. And then in our second presentation, we talked about living in space and finding a way to get there using private industry and all of the amazing advantages that it has shown to the public, especially in the past 10 years. That seems like a total non sequitur, but philosophically speaking, there is a link between those two things, and it's this. The first question was asking, do we have neighbors in the solar system, living of some sort, bacteria, squids on Titan, you name it. And the second question is, that we heard from Loic, is how can we move in there right now? So when you're looking for a place to live, you look at the neighborhood and you look to see who your neighbors are. And that gets back to my first non sequitur, which was property. In space right now, we're assuming, and this was touched upon in the last Q&A session, we're assuming that when we go out there, we have free reign and total absolute right to claim what's out there. I mean, space law, what little there is aside. So the question that we want to pose to you in this jam session, the thing that we do at the end of every meetup, is this. What do you personally think will be how property rights are resolved at some point, or at least initially negotiated in space? And what do you think the best way is? So when you're all discussing and talking and going back and forth in discussions, think about those two questions. And as always for this jam session, we're going to try to kind of reorganize ourselves. So for this part, I'm going to actually ask you guys to all kind of get up and kind of get a circle so we're not all staring at the stage, because I'm about to get off of the stage, and then we're all going to just talk with each other and see what we think, see if we can come to a useful conclusion, or at least learn a new thing or two today. Sound good? Yeah? Yeah. Awesome. All right, guys. So let's try to get a rough circle with chairs and standing room if we have to around the middle, somewhere around here, and we'll break into it. Eh?
People can start taking their seats. We'll get started. It's getting close to 9. So can we start? Okay, so I see a lot of new faces. So let me just explain what we would like this, how with this ideally we would want it to be. So this is going to be very little participation from the organizers of the meetup. We want it to be a conversation amongst the audience mostly, hopefully building on each other and getting to a point where people start learning something from each other and having a conversation amongst yourselves. So expect to hear very little from the Space Cooperative people who are organizing the meetup. The speakers are obviously welcome. Okay. Yes. But the most important thing is it should be an organic conversation, and it's not going to be like, yeah, you talk or something. Let it be a conversation. Okay. So go.
So the prompting question is, how do you think property rights as a concept in space will be resolved in the near term, and how should they be resolved? And that's like the thematic discussion for all this. So we're just going to pipe in on each other's conversation, just kind of do an informal debate. So to kick things off, I will play the Ayn Randian total advocate of privatization and objectivism and say, we have to privatize everything in space and give everything a dollar value. Otherwise, it'll be a free-for-all, and astronauts will have like just no control over their own resources, and it will be a bad day for everybody trying to breathe. So comments, opinions?
First question, will there be property taxes if the properties have value? And if so, then can there be country clubs that circumvent the property tax like like golf country clubs did, in the sense that they only pay property taxes that are pre-1978, which I can get into later.
So I just actually want to go in the opposite direction. Why do we want to replicate something which is on Earth, which is obviously causing a lot of trouble for a lot of people here? Money results in issues, right? Do you want to like move away from the current kind of economy we have on this planet to something different, like a different form of governance is based on resources instead of just monetary money, which promotes more selfishness among people? It's just the nature of exactly. There was a recent experiment. You put two AI bots together and give them a money like commodity, they start killing each other. Give them a resource like commodity, they start working with each other. This is AI. It's not even humans. It's just a natural process that people evolve into competing and then start fighting each other over things which are scarce. So why do we want to move towards that kind of governance which allows scarcity to even happen in the first place? So I think you should just move away and do a completely different turnaround on how you want to govern.
So this isn't a comment, just a quick question on this experiment that you're citing, or whatever it is. Can you guys all hear me? Is there some weird interference? Oh, yeah. In this, when you say monetary versus resource, like what was the distinction between them that made one different than the other?
I was just saying like something which is not scarce. Scarcity is the issue. I mean, once you create scarcity, people will start fighting each other, and there will be people who will take advantage of people who are not in the right in the right time at the right place. So that's all. But I mean, I don't want to like start a fight here. Money versus no money. That's not the point here.
So I think most people would agree with your premise. Let's not kill each other. I think it's a good kind of guideline for society. I guess the question is more, what else do we do? I'm asking you actually while you look at me. Yeah, that's kind of the question. So I guess it's a good question.
So I mean, my first addressing the first few comments, which were, were about trying to replicate Earth systems or, deciding things on Earth. It seems that I mean, if you set up some sort of system of taxation or privatization, I mean that assumes that you have somebody that's controlling it, and even more like opening up to the general idea seems to be like people that are on Earth deciding how the moon is going to be run or something. It seems like if we came up with a system, even like an ideal system of something new that's not replicated on Earth, you're faced the problem of how do you enforce that, or how do you prolong that or project that from Earth if you're trying to make people on the moon decide what to do? It seems like that a solution to the problem of resource scarcity would ultimately be found after competition starts on the moon. The first two companies or governments that find themselves in a dispute over who gets to claim a resource patch on the moon will, for better or worse, set the precedent on how things like that will be handled in the short term. And I don't have an answer on how that might be solved, but I guess when I think about the prompt, I'm wondering like of a situation where SpaceX and a Russian company trying to mine the same patch of land, what do they do? And I don't know, but it's an interesting question.
I wonder what's the value of leaving things intact and not touching them at all. I mean, we're assuming that they should be harvested, mined, whatever. But I mean, even now in archaeology, they know to leave at least a part of it sort of behind for the hope that future people who come along are smarter, wiser, more knowledgeable about how to use it. So what's to say this is the right time for us to even be doing this?
I was gonna say, I don't think it's about the right time, but it will happen eventually. So we have to think about it.
I was going to build on the comment that you made. What if SpaceX and a Russian company are trying to mine the same piece of land? We are Americans or Russians or Chinese or Europeans on Earth. Once we've left Earth, are we still retaining the same citizenship rules? For the most part, country definitions have revolved around resources. Yeah, there are cultural aspects to it, but for the most part, it's been resources. We are all, as nation states on this earth, trying to preserve resources for our people. That's nationalism. Once we're in space, are we still responsible to the same level of nationalism that's not on that planet? Or are we some sort of a global citizen that has a completely different view of nationalism that's now trying to protect its resources from Earth, possibly?
I think that'd be a great way that it could work out. I think one of the hurdle with that is we're going to come initially leveraging resources from Earth, which come from a country or another or a company or another. And those vested interests, people will expect return on them because that's just kind of how our system works. Except again, if say Space Corp grows to a point where they can make their own colonization mission and everybody with a cryptocurrency can be gone. And that's one way to do it. But until we rely on our current social / economical and say country model, if SpaceX get into space, even if it's a SpaceX astronaut, even if they say, well, now I'm a global citizen, SpaceX gonna say, give us back what we paid for. And until then, we're stuck.
So I don't know if anyone here plays Settlers of Catan. Anyone? But anyone who's played the game, so you have like these different resources and you use these resources to build cities or acquire certain development cards and stuff like that. So you got ore, wheat, sheep, iron. Iron's not one of them, but anyway, the point is like there's no specific point in time where all of these resources are valued equally. They all fluctuate in value based on supply and demand, right? And I think that goes the same with like technology as like right now, oil is very valued because right now it's our most readily available resource for, burning and creating, powering power plants and so forth and whatnot. But as technology progresses, we'll be able to maybe extract energy more efficiently, such as through solar power, in which case the value of oil would drop because there's not as much demand as. So whether we give it a cryptographic or monetary or whatever sort of value, there's always going to be this intrinsic value of does anyone want it, which I think will change over time and based on supply and demand. And ergo, the ultimate premise is so long as conscious entities have a need for physical resources, there will always be a value fluctuation.
So I agree with your point. Only until if there's no scarcity, then the value doesn't really matter, right? If there's enough for everybody, how does the value matter then? So it's true as long as we stay with that value-based system of assigning values and scarcity towards two things. If we completely view it from a different angle, then we don't have that problem.
But who really determines who it belongs to and how much, is it equally given to everybody, or is it first come, first serve, or I found it and it's mine? Like that's why even when you talk about property, when if America sends a mission to say Mars and then they develop a whole thing, so doesn't that belong to America? India can't come and say, okay, we want a part of this as well, and they can't just. put their place there. Anyone else wants to take them?
To your point about that, like you could just look at the colonies in the way that England was here, and now there's independence for the last couple hundred years. So I'm actually a real estate agent, so I love the fact that you brought up this topic. I'm a real estate agent, and I'm also a major space and exploration fan. I'm not a scientist or anything like that, but in real estate, you own everything from the center of the earth up through the sky on your property. And so if there are resources there, if each party was sovereign to their efforts there, for example, like in Detroit, there's a stimulus package. If you go and buy a house in Detroit, you can get $20,000 to start a business or whatever the case may be. So maybe there's that type of global stimulus package. And I wanted to comment on one thing that he was saying earlier, which was that, wow, I'm out of breath. I got nervous because you guys are all looking at me. The other thing I wanted to comment on was basically that, I forgot. Well, anyway, I do this for a living too. That's weird. But yeah, this is a cool topic, the real estate in space. So anybody else want to take this now? Yeah?
I think probably it'll be, like in America, where it's basically like homesteading. If you come and you build a house or you mine it, it's yours until there are so many people that all the stuff is, claimed, basically.
Well, coming to a question that who decides which country gets which resources. So I was thinking maybe we can set up a system or society like United Nations, or maybe it's called United Space. And then the one company or the one government who goes there, maybe they can decide that 50% of the resources they mine, that can go to United Space so that it helps in developing future resources. And maybe after 10 years, when we have enough of resources, maybe we can get the privatization, like the system earlier works in the governments. First, we have social system. It helps building the society, and then the more privatization, it generates competition, and the prices go lower after that.
I guess it's probably worth thinking about the path in which this would get there and what that implies. So in terms of, you imagine that country A sends up its colony, decides it's time to start a colony, or a company under the auspices, that's registered in company A starts a colony. And that implies that therefore that whatever that colony is under the obeys the laws of that country. And eventually other countries do it, and they reach sort of an agreement that what happens on Earth applies in there. It's you establish your land, establish your boundaries, and the laws of those countries pervade, and etc. This continues on. Then further down the line, the colony on the planet then resents the fact that it's paying tax to the country which tries to secede, and then you end up with a country which is located on a different planet or whatever body. But you see where I'm going with this, and that essentially if we base it on the path we have now, it would end up essentially with the same sort of nation state that we have at the moment, just transferred to a larger galactic area.
And we'll still be fighting among ourselves.
Hi. I was just thinking, I always, when I'm doing thought experiments or any kind of discussion, I'm always thinking about myself, like what would I do in this situation? And I was just thinking how unwilling I would be to live off Earth. I'd just die, let myself die. So I was thinking, I was just thinking about the scarcity problem, and I was thinking like how many people out there would be like me? Would there be a lot of people who would choose, like I'm claustrophobic. I can't live in those little pods. Like there's just no way. I'm not willing to. So I was just thinking about like how many people would be unwilling, would just be happy to die at that point. And then would that resolve some of the issues regarding resources? Any willing suicide attempts?
I'll try to respond to all three last speakers. I mean, for one, and it's a bit of a dark thought, but I guess we have to entertain it. I still think there'll be enough people left who wants to live that we still have to figure out. But I mean, yeah, for you, I think, I mean, what we're getting at is essentially that if we do that, we'll just end up exactly at the same place that we are today, and it's really not helpful. Yeah, I understand. And so one thing to lead to another until you have a complete galactic order, if you will, and everybody fights everybody, and we just even worse as we are today. It is a sci-fi novel, but push enough years and it's a reality. To Isha's point, I think it's a really good idea on paper. The only problem I see with it is who's gonna make, say, the company who goes there first give up half of their resources to anyone else. And how's it gonna do that? Just wait there. Yep, I think the United States tried the same thing when settlers came in, and it didn't really work out just because if you don't have a, I guess, incentivized path to actually make people do it.
I mean, the United States body is already funding the company. They have the stake.
You assume.
They have the regulations. If the regulation goes for next 10 years, so it's the same thing for all the companies in those 10 years. So there's no point. And this 50% funding is already going in the maybe next future mission exploration or something like that.
So that would work, but I think today companies can go on their own, and they don't need any support from anyone. And so if they do that, like SpaceX today can go on the moon and settle. They won't because it's not in the stakeholder path and it's not bringing enough money, but they could if they wanted to. And if they do that, no one's going to be able to tell them, give us half of your stuff. I don't think.
Companies are going, they need, I would say if the companies are going its own, then they definitely need a rocket or some kind of permission, as you were saying, that if they have to launch. So these regulations could be more improved, that if the companies have to launch something in space, so as I mentioned, this body can be made and they have to take more regulations. We don't have no regulations right now. So this regulatory committee could be there, and then this setup can be done. Yeah.
So I'm not an expert in anything, space or non-space. I'm just gonna put that out there first. But I definitely agree with the whole United Space idea that, I mean, if we don't start leaning towards some sort of supranational governance or regulation thing, humanity always falls back. If you don't have governance, humanity always falls back to might makes right in the end. As far as I know, there's no natural occurring anarchic like utopia on Earth, right? So who's going to force the companies to do whatever? Like who's forcing companies to do stuff now? Well, government. So there has to be some sort of supranational body, right? Or because different countries can't have different rules, obviously, because like we're all leaning towards the same problem always then. Well, they have their rules, we have our rules, so I'll just scavenge off of India's pods when we get there, and we don't have to bring our own stuff because no rules. Like, yeah.
Speaking of rules, guys, we've got time for a couple more questions, then we really got to get out of here. And on the subject of power, if we don't get out of here soon enough, this might be the last one ever. So when we do close up, please be kind of a courteous guest. Chairs roughly back where they were when you guys got here. And on that note, 2 more comments.
I actually had a very similar idea as yours, but I wanted to make 2 comments on the governance part and then the idea of defining property. So on the governance part, I think a lot of people made a lot of points, and it's interesting the evolution of governance. We went from feudalism to democracy today in some shape or form, but it's so hard to think beyond the nation state just because perhaps our cognitive intelligence, someone mentioned intelligence, is not there yet. That reminds me of Ken Wilber and his spiral dynamics, where there's a few people that can think beyond the paradigm of today. And I, for sure, am one of those people. I don't even know what beyond the nation state, but thinking beyond what's next on the nation state on a societal cognitive level would be interesting. And then defining property. Well, property today is like a physical place. You mentioned from the, you earn a certain square footage from all the way down up, but what if, property is something we experience and we have, and what if the technology or the space that we had in the moon or wherever could be malleable, and you could buy time or whatever in a certain amount of space for a certain amount of time because you want to experience that. Like when I was 15, I wanted to experience something different from like at 30, you know what I mean? So I don't know, that may be a different way of looking at property itself.
Thank you. I'm probably going to be I'll probably be the worst person to speak last. So if someone wants to speak after me, that'd be great. I'll get back to you later. So I think just in observing the discussion that we've been going back and forth on, I think there's like a few things that we kind of have to acknowledge we'll deal with. One is scarcity in something. Maybe some things will be plentiful and we won't have to worry about it, but other things will be scarce, and we will have to find some way of working out who gets to use them, who owns them, however you want to put it. The other thing is human nature. Like, we're really probably not going to change. I mean, like we have evolutionary pressure up to a certain point, but right now we don't really have it. We don't have any pressure on us to do anything fundamentally different than who we are right now. So we're going to have to deal with ourselves as we are. Like as we are in this group, as we are in the outside world, and all of that. And then there's one big thing and that's the unknown. I mean, like Loic and Nathan were talking about what's in the near future, what's in the far future, but really this is all guesswork right now. We don't really know for sure what's going to be like. We get out to Mars, situation could be way different than what we're hypothesizing right now. And so like, while it's good to discuss having some overall governing bodies, it's hard for us to say like, we're going to put something in place right now that will be perfect and will work for everybody. We need to have something that allows for evolution, something that allows people to adapt to their local circumstances, because who am I to dictate how somebody living on Mars lives, right? I would have absolutely no idea what they're going through, what their situation is. Same thing, somebody living on Europa or Titan or wherever. What does Mars have to say about that? There might be some similarities, but there's going to be a lot of differences too. So, I mean, I think this is great. I think I've had a lot of fun listening to all of you, but like I said, I think we have these fundamental things we're going to have to deal with, and the unknown is one of them. And we're going to have to evolve, and maybe these ideas will come forward, but we're going to have to test them out and see what actually works. I mean, that's my 2 cents on the matter. Oh God, that was terrible, but.
No, I was just going to add a little bit of hope in that picture, and that probably way back when in Europe, when people were starting to go to the States, they might have the same kind of discussion, just not with wine and beer, but something else. And obviously, they found an answer that did not go much further than where they were, but they made it work. So I think regardless, we have the ability to make it work. It may not be the shape or form we envision or would like today. It may not get where we want it to do either, but we made it go. We'll make it work.